The dream of traveling to other stars isn't just science fiction anymore. It's becoming an engineering puzzle. But how do we even begin to solve it? Imagine looking up at the night sky, picking out a star, and knowing that someday humans could be standing on a planet orbiting it. It's a thought that fills you with wonder, but also with a huge question mark. How do we get there? It's not as simple as hopping in a car or even a jet. The distances are mind-boggling, the speeds needed are terrifying, and the energy required makes our current technology look like child's play. Today, we're going to dive into the wildest, smartest, and most hopeful ideas for how humanity might finally reach for the stars. We'll explore everything from souped-up rocket engines to bending space itself, and even how we might just sleep our way to a new home. The first hurdle is truly understanding the sheer crushing scale of space. Our closest star system, Alpha Centauri, is about 4.3 light-years away. That sounds like a small number, right? Not really. A light-year is the distance light travels in 1 year, and light moves at an astonishing 300,000 kilometers per second. Even if we could somehow travel at the speed of light, it would still take us over 4 years just to get to our nearest stellar neighbor. Our fastest human-made object, the Voyager 1 probe, is currently hurtling through space at about 17 kilometers per second. If we pointed Voyager 1 towards Alpha Centauri, it would take around 70,000 years to get there. That's a journey longer than recorded human history. Then there's the problem of getting anything moving that fast: fuel. Rockets work by throwing stuff out the back very quickly. The faster you want to go, or the more you want to carry, the more fuel you need. This is what scientists call the tyranny of the rocket equation. It means that for every bit of speed you want to gain, you need an exponentially larger amount of fuel. Think about it like this. To send a tiny payload to a star in a reasonable amount of time, you'd need a rocket that's almost entirely fuel, maybe the size of a small moon, just to get a soda can-sized probe up to speed. This isn't just an engineering headache. It's a fundamental roadblock that chemical rockets simply can't overcome for interstellar travel. We need a completely different way to push ourselves forward. So, if chemical rockets are out, what's next? The answer might be staring us in the face every sunny day: fusion. Fusion is the process that powers the sun, where light atomic nuclei combine to release enormous amounts of energy. Imagine if we could harness that power here on Earth and then use it to propel a starship. Fusion power is incredibly dense, meaning a small amount of fuel could produce a colossal amount of energy. This energy could then power advanced drives. One example is the Variable Specific Impulse Magnetoplasma Rocket, or VASI-MAR. This isn't a fusion rocket itself, but it could be powered by a fusion reactor. It superheats gas into a plasma and then uses magnetic fields to shoot it out the back at incredible speeds. VASI-MAR offers very high exhaust velocities, which is key to overcoming the rocket equation. The catch? It produces low thrust. So, while it could speed up travel within our solar system, cutting a Mars trip down to a few weeks, getting to another star would still take centuries. The real game changer would be direct fusion rockets. Instead of just using fusion to generate electricity, the fusion reaction itself would create the thrust. Imagine a controlled mini-sun driving your spacecraft. Concepts like Project Daedalus, designed in the 1970s, envisioned massive fusion pulse rockets. These would detonate tiny fusion pellets behind the ship, using magnetic fields to channel the resulting explosion for thrust. Daedalus was theorized to reach Barnard's star, 6 light-years away, in about 50 years. That's still a multi-decade journey, but suddenly, it's within a human lifetime, or at least a few generations. The challenge? Making a fusion reactor small enough, robust enough, and efficient enough to do this is still decades away, if not more. What if you didn't have to carry all your fuel with you? That's the brilliant, if somewhat crazy, idea behind the Bussard Ramjet. Proposed in the 1960s by physicist Robert W. Bussard, this concept is essentially a cosmic snowplow. As the starship travels through interstellar space, it would deploy a massive magnetic field. Picture a giant funnel, thousands of kilometers wide, to scoop up the sparse hydrogen atoms floating between the stars. This collected hydrogen would then be compressed, heated, and used as fuel for a fusion reactor on board, providing continuous thrust. The incredible appeal of the Bussard Ramjet is that it could theoretically accelerate continuously, potentially reaching a significant fraction of the speed of light, say 10% or even more. At those speeds, a trip to Alpha Centauri might take only 40 years, which is suddenly very doable. No more worrying about carrying all your fuel. The universe becomes your gas station. But of course, there are monumental challenges. First, that magnetic scoop would need to be absolutely enormous, stretching for thousands of kilometers. Generating and maintaining such a powerful field would require incredible amounts of energy. Second, interstellar space isn't completely empty, but it's very, very thin. Collecting enough hydrogen to keep a fusion reactor going would be like trying to drink from a garden hose with a straw while running a marathon. There's also the problem of drag. Scooping up all that hydrogen would create resistance, slowing the ship down. And finally, getting the initial fusion reaction started and sustained with such sparse fuel presents a serious engineering hurdle. It's a tantalizing idea, but still very much on the drawing board. Now we enter the realm of pure speculation, the kind of stuff that makes science fiction writers giddy: warp drives. You've seen them in movies and TV shows, instantly jumping across vast distances. The most famous theoretical concept is the Alcubierre drive, proposed by physicist Miguel Alcubierre. What's mind-blowing about this idea is that it doesn't involve moving faster than light. Instead, it involves distorting space itself. Imagine your starship sitting inside a bubble of normal space. The Alcubierre drive would then compress the space in front of the bubble and expand the space behind it. It's like standing on a moving sidewalk that's moving faster than you could ever run. You're not actually moving fast through the sidewalk itself, but the sidewalk carries you across a great distance in a short time. This means the ship inside the bubble never actually breaks the speed of light locally. From the perspective of an outside observer, though, it would appear to be traveling much faster than light. Sounds amazing, right? The catch is enormous. To create this warp bubble, you need something called exotic matter. This isn't just a fancy name. It's matter that has negative mass energy. Think of it as matter with negative weight. We haven't ever observed exotic matter, and our current understanding of physics suggests it might not even exist. Or if it does, it would be incredibly unstable and almost impossible to create or control. Even if it did exist, the amount needed for a warp drive could be astronomical, enough to consume the energy of entire planets, or even stars. So, while warp drives offer the ultimate solution to interstellar travel, they remain firmly in the realm of theoretical physics and the very, very distant future, if they're possible at all. What if none of these propulsion methods pan out in the near future? What if the distances are simply too vast for any reasonable travel time, even with advanced fusion drives? Then we have to get creative with time itself and how humans experience it. This leads us to two other fascinating, if daunting, concepts: generation ships and sleeper ships. A generation ship is exactly what it sounds like: a gigantic vessel, an entire self-contained world, designed to sustain multiple generations of humans over centuries, or even millennia. The crew that leaves Earth won't be the one that arrives at the destination. Their great-grandchildren, or great-great-great-grandchildren, will be the ones to step onto the new planet. Think of it as a small, traveling city with its own ecosystems, agriculture, and society. The challenges are immense. Sociologically, how do you maintain a sense of purpose and direction over hundreds of years? How do you prevent internal conflicts or genetic drift in a small, isolated population? Biologically, how do you manage disease in a closed system, ensure genetic diversity, and keep people healthy without the variety of Earth? And practically, how do you maintain a complex machine like a starship for such an impossibly long time without spare parts from home? It's a huge ethical and design puzzle. Then there are sleeper ships, which try to sidestep the generational problem by putting the crew into some form of suspended animation or stasis. Imagine going to sleep for hundreds of years and waking up at your destination, having only aged a few moments. This would solve the psychological and sociological issues of multi-generational travel, as the original crew would be the colonists. However, the technology for human suspended animation simply doesn't exist yet. We can induce hypothermia for medical reasons, slowing metabolism, but we can't truly freeze a human and revive them without severe damage. The ethical questions are also profound. What happens if you wake up thousands of years later to find your destination planet uninhabitable, or that Earth has been destroyed? What if humanity has advanced so much that you're considered a relic? The idea is tantalizing, but the science and ethics are still way beyond our current grasp. So, from slow, powerful fusion engines to scooping hydrogen across the cosmos, to bending the very fabric of space, and even trying to sleep through the journey, humanity has no shortage of bold ideas for how we might reach the stars. Each concept comes with its own unique set of mind-boggling problems, but they all share one thing: the enduring human spirit of exploration. Which of these incredible ideas do you think will be the one to finally get us to the stars? Let me know your thoughts in the comments below.